Welcome, everybody, to DevOps Drinks. It's the news show all about digital innovation. I'm Gina Smith.
I'm Michael Araneta.
And later on in the show, Michael, we're going to have Nikolai Petrovsky. He's a professor at Flinders University. He's the co-founder of a vaccine company called Vaxine that has a COVID vaccine in the works. But what's interesting is he's using cloud technology provided by Oracle, actually, to sort of create a virtual pharma company. It's really interesting stuff.
I'm very excited to talk to him, obviously, because we want to find out how the movement to find the vaccine for coronavirus is gathering pace. So quite interesting set of developments there, I'm sure.
Yeah, he's an interesting guy. He'll join us in just a minute. But first, the news. It looks like software development is, well, I wouldn't say bouncing back, but it's starting to turn back up. We were just talking about this, Michael. Sonatype, which are the people that run a giant database of open source components, say that it's starting to turn back up.
It is starting to turn back up. The numbers, I think, for China and India were down 21% from the beginning of the year, or at least the beginning of the outbreak. But I think it's starting to show back some signs of life, which is quite interesting. So everyone's back at work, although at home, but I think they're downloading all the open source technologies that they need.
Yeah, just a little background for you. Sonatype measured coding activity by download based on all these open source libraries it has. I'm looking at the number. They have 330,000 Java components on the central repository. It's used by about 10 million developers. So what they did was they looked at 7 countries? The US, UK, China, Germany, Spain, Italy, India, to try to determine if developers are downloading at the rates that they were last year. There were 246 billion download requests. They're not going to hit anywhere close to that.
Although I think the numbers for what we have currently would indicate that we're sort of back at the level of end of last year. So I think, we've regressed to end of 2019 levels. But hey, I mean, it's been a big outbreak, and it's been a big systemic event. Yeah. So I think we're good to be back at that level.
Yeah, that's right. What's interesting to look at really here, and we can pull up those figures, is China, because they started recording this data in January of 2019. It goes all the way through last month, April of 2020. Mm-hmm. If you just compare February to February, you see China's got about a 30% year-over-year decline. But now they're rebounding, and even though they're still about 18%, you said 21%, something around there, what they were last year, there is kind of a U-shaped rebound, and at least the statisticians over there think that India and Europe and the US will follow suit.
Yeah. Of course, if you look at the graphs, you would notice that January of 2020, just around the New Year's, no one was downloading anything for obvious reasons that we were just celebrating, right? But there's a huge inflection point from December 2019 to around the New Year's, and then everything was moving back up until the outbreak, obviously.
Yeah, that's something that viewers outside of Asia should be reminded. Of course, we have Chinese New Year, so it always bottoms out around January around here, as it does, between Thanksgiving and Christmas in the West. But interesting stuff. So here's what else isn't slowing down is acquisitions. Did you notice all the acquisitions in the news last week? Venafi is buying JetStack, so that's open source identity protection. So that's one thing. VMware, which has just been kind of on a tear, is buying Octarine and adding that in to its Carbon Black, which it bought last year for a couple $2 billion. And then before that, it bought Heptio, which of course was started by the Kubernetes guys, a couple of the Kubernetes guys, McLucky and so on over at Google. And then Verizon bought Blue Jeans.
That's interesting. Yeah, there's movement, obviously, to really stay ahead of all these work from home type of initiatives, right? And Blue Jeans, one of the apps that would enable a lot more collaboration between workers, teams, and co-workers as well. Finally getting a buyer.
Yeah, that's a $500 million purchase. I guess Blue Jeans was quoting about 15 million enterprise users. They're a lot bigger at enterprise than I think most people give them credit for. Of course, everybody's talking about Zoom, right? Zoom, and 300 million users. And then the Google Meet is now free, the advanced features, anybody with an email address. And I bet you Amazon Chime is going to announce something.
Right.
I
And
mean,
of course, Teams too, finding a couple of fans everywhere. But very, very good movement here. This just really facilitates the new way of work that we are experiencing at the moment.
and I like it, actually. I'm used to it.
Yes.
You know, it used to be we would all get on Teams, at least at IDC, we'd get on Teams and we'd all turn the video off and we would just, use the audio and kind of, walk around your house or your office. And so it's become more personal. People talk about these video conferencing wars. And I was just thinking this morning, there doesn't have to be one winner.
There's how many billions of people in the world who can get access to these for free. Obviously, some of them are on enterprise-wide type of licenses. But yeah, you can end up with maybe 10 of these popular platforms. And yeah, we'll all live in peace.
we'll all be able, there's room in this town for all of us, maybe. Well, I guess
That's right.
a Microsoft shop or a Google shop, I mean, it really matters. But
Yeah.
it'll be very interesting to watch at least some of that shake out. And as I said, Amazon Chime, which is something you never hear about or as much about, they've been really weirdly quiet. So my prediction is something will be announced there.
I've used all of them over the course of the past year. They have their advantages, and some of them would have disadvantages. But I think, yeah, it's also quite interesting to look at what features they are making more prominent in these platforms.
Yeah, well, for sure, Zoom is trying to catch up in terms of the security and the Zoom bombing. The new version of Zoom 5 is out now. They're always trying to force that on you when you log in wisely. Google has some great security features that they've announced, in terms of encryption.
Yes. And yeah, you have some agile teams that are choosing one or two platforms to work on, especially as they do their daily stand-up meetings. So this has been part of all these platforms have become part of the culture of DevOps and agile that we are seeing right across different enterprises across the world.
Yeah. It'll be very interesting in the end is the Verizon Blue Jeans purchase. Verizon having access to all that 5G technology.
Yes. Yeah. And which means that Blue Jeans might be super powerful.
Right. And in the end, it's all about bandwidth, right?
Yeah, that's right. And back to acquisitions, you just really wonder, how exactly these one will then be, I think, incorporated to the enterprise technologies that are being invested in by different organizations. There's identity, there's security, obviously, there's cloud optimization technologies. There's a lot of new technologies that are being brought to the market, but nobody seems to be buying.
Yeah. And I think user experience and user interface is going to make such a difference. I mean, this is the reason I often choose Zoom over Teams, as I find it just more accessible, but then everybody has their preference. Yeah.
That's right. Yeah.
Very interesting stuff. All right. Well, we should get Nikolai Petrovsky on here with us, because we've been talking so much, of course, it's all in the news about the COVID pandemic and how all these tech companies are offering up free infrastructure, cloud technology, supercomputing space, et cetera, to enterprises and companies working on COVID type projects. Oracle is one of them. And Oracle turned me on to Professor Nick Petrovsky, who's using their infrastructure to really speed identification of treatments using protein folding and proteomics. And the company, and he's interesting too because he worked on the SARS vaccine.
There he is. Nikolai, he's here. Nikolai Petrovsky joins us now, the professor. Hello.
Good morning or good afternoon.
Good morning, Nikolai Petrovsky, Director of Endocrinology at Flinders University, the founder of a company called Vaxine that does just what it sounds like, makes vaccines. Yeah. And congratulations, you have a vaccine for COVID-19 in animal testing, we hear.
We do, yeah. It's quite an exciting time. Obviously, there's still quite some work to do, but we're moving along pretty fast.
This is very quick. I mean, when would you have had to start on this vaccine? I mean, most of us just learned of this in early January, but you were also working on the SARS vaccine years ago. And I guess
so we've been supported by the US government for really the last 18 years to work on pandemic viruses and pandemic vaccines. So we've really been trying to develop a platform that when we're faced with a pandemic out of the blue, we're ready to go day one and roll out that platform, develop a vaccine and get it into humans as quickly as possible.
Which is just the opposite of how most pharma companies work.
But
right?
Nikolai, this is also quite an impressive, I think, initiative for the entire world. I mean, IDC has been talking about this particular COVID-19 situation we are in as the biggest experiment for work from home. And we've been covering that a lot. But this is also the biggest initiative for all the scientists that matter to work on finding the vaccine, right? And I think in terms of speed, but also in terms of the focus. And I think we've never seen anything like it.
Yeah, like essentially this is what sorts out the scientists, who are able to deliver from those who are not, because it's real life. A lot of the time in science, people, talk about theories and, do work that is relatively basic science, trying to understand mechanisms. But, here we've got a real global problem that needs to be solved overnight. And science is the only thing that can solve it. And so, as I say, it's a way of distinguishing the real science from the other science, the science that's more theoretical but not practical.
So the way we were hooked up with you is we were talking to Oracle, and Oracle is one of several large tech companies who are offering free cloud resources, computing power to organizations like yours, right, that are looking for treatments, looking for vaccines. But for you, it's something more, isn't it? It's really creating a whole platform to quickly develop treatments for this and all future pandemics? Is that the idea?
Yeah, so, in terms of computational research, again, a lot of people work with supercomputers on very theoretical problems. The difference with us is we're always just trying to bring new technologies to bear on the problem, which is how do we deliver pandemic vaccine faster than has ever been done in the past. So when we approach people like Oracle and utilize their supercomputers, it's not to address some theoretical problem. It's actually to address real world problems like how can we make a vaccine faster than we've ever done it before? And can we use your supercomputer so that we can do it even faster? And so, we're really looking to use these technologies for a very practical purpose. And I think that distinguishes it from a lot of the other science that's done on supercomputers.
Can you give us an indication of the extent, the size of the compute requirements that you have, and also how Oracle has been able to meet those requirements?
So in this case, we're doing a lot of work on GPUs, which obviously are less available on the cloud than CPU clusters. Mm-hmm. At the moment, we're utilizing 10 GPUs within the Oracle Cloud, and then we're using some large CPU clusters as well. So for some problems, we need the CPU clusters. For other problems, the GPUs are far more efficient, particularly the molecular dynamic simulations, which, on CPUs might take months to run. We can get them completed running them on it for a few days on the GPUs. So particularly for the modeling side of it, the GPUs has been really critical, I guess, to our efforts.
For modeling the proteins and the protein folding, all of it, trying to run through as many possible chemical candidates as possible.
Yeah, exactly. So we're simulating protein structures because at its heart, all vaccines ultimately are three-dimensional structures, typically of proteins, but also of glycoproteins, so proteins covered in sugars. And so to get a good vaccine, you have to understand the structures of the virus proteins. And of course, although you can ultimately do that by X-ray crystallography, that's a very complex and time-consuming task. And for some proteins, they never get solved. They're just too difficult to crystallize. So the beauty of doing a simulated structure is that we'll always get a solution. Now, hopefully it will be the right solution, but at the very least, we will get an idea of the structure of that viral protein. And as I say, that's the whole starting point, the building block of designing a vaccine is understanding the structures of the virus that you have to target, or you have to get the immune system to target and use your vaccine to do that. So structures are really key to developing good vaccines.
Yeah, you're trying to block that little spiky shape, right, on the coronavirus, the spike protein.
Yeah, so the spike protein is in fact what gives the crown shape to the virus. It projects out from the surface and gives it those spikes. Mm-hmm. And it's that spike protein that attaches to the human cells in the nose and in the lungs and allows the virus then to get inside our cells and infect them. So if you can, either destroy that spike protein structure, or if you can get an antibody that binds and blocks it so it can't bind to the cells, then the virus becomes harmless. It can't get inside and it can't infect us. And so that's what we're trying to achieve with our vaccine.
Based on what we know so far, is this a COVID-19 coronavirus that's difficult to create vaccines for? Or it's just really that normally it takes a longer period of time for us to find a vaccine, but this is in a much shorter time frame. What is the challenge?
Yeah, so if you look back in history, typically a new vaccine, takes about 15 years to develop. It's not a simple process, and there are a lot of steps. There's a lot of complexity, and then there's a lot of testing. Even once you have your candidate, you can have up to 10 years of testing in animals and then in humans before you get approval for the vaccine. So, we're trying to compress that 15 years into 15 weeks. That is no simple undertaking. And it means that you have to shorten everything. You have to shorten the design phase, the manufacturing phase, the animal testing phase, and the human testing phase. Everything has to be compressed and done in parallel. So it's a crazy undertaking because you can't just do everything, in a normal linear fashion. So it's a bit like parallel computing, and the whole principle of parallel computing, except that's not normally applied to vaccine development. So vaccine developers are much more attuned to the linear programming way of doing things than the parallel programming. And so I guess that's what we're trying to do is do everything in parallel here. And, that gets a little crazy at times.
And even though you're doing it fast, this has got to be really painstaking work, right? You don't have to go very far in history to read all about vaccines that were tragically detrimental to polio vaccines, right? There were vaccines that caused lasting damage to people. And so
vaccines are obviously never approved until, they're established to be safe. And that's why so much testing, rigorous testing goes into them. And so, although we are trying to shortcut the process, we're certainly not trying to shortcut, the establishment of safety. You just have to, I guess, try and redefine how do you prove safety? How do you establish safety? Are there tests that you can do that will give you those answers more quickly? But in no way is anyone suggesting we should bypass you know, the need to prove that the vaccine is safe before it's delivered, you know, to a lot of people. So
given that
it's
this
challenging
is
for that reason, because a lot of the time in developing a vaccine is all about establishing safety.
Right.
sure.
So that is quite challenging, how to shorten that time.
It's an interesting horse race when you think of it, because the U.S. NIH, the National Institutes of Health, they're funding you, right? But they've got to be funding plenty of other horses in the race.
Yeah, well, you know, what we try to encourage the government to think about is, you know, if you back one horse in a race, your chances of losing are enormous. And when you're dealing with a pandemic, you can't afford to lose. So what we're encouraging them to do, back every horse in the race. So give resources to everyone who's credible and has a candidate. Don't just give it to one or two, even if they look to be the best and they're the shiniest, or they talk the most, or, you know, they have the most exciting technology. This is not a time to pick winners. It's really a time to you know, put the resources across the board and back every horse that's legitimately in the race. Not to say, you know, backing the number 100th, you know, project that's, you know, some mad scientist in the middle of nowhere puts up his hand and says, I think I can solve the problem. But you know, take all the legitimate projects and give them all some support, and then let them work out, you know, based on their performance, which one is going to succeed, and hopefully multiple vaccines will succeed. We don't want ours to be the only one, because, you know, we can't supply a market of 15 billion vaccines, which, you know, may be what's needed. So we want there to be multiple winners, and certainly we want our vaccine to be one of those.
So I was telling Michael,
to be the only one.
Well, that's it. And every vaccine company is going to have to worry about vaccines for their own geography. So you'll see Chinese vaccines, Australian vaccines, US.
Yeah, so the world's a big place, and I think that is going to be one of the challenges, is making sure that vaccines are available equally in all countries across the globe, because, you know, most of the vaccine manufacturing is concentrated in a few countries, you know, particularly in the US and in Europe. There's very little vaccine manufacture in Africa or, you know, South America, and you know, there's enormous numbers of people in those places. So what do we do if we can't get them vaccine because there's a, you know, government says, well, we're not going to allow you to export your product, you know, from the country in which it's being manufactured until you satisfy the local market, which could take years. And so I think there's an equity issue, which I know WHO are starting to talk about how do we ensure that all countries around the globe get access to the successful vaccines. And I think that's going to be a real challenge. We have one model of doing it, where we're basically proposing to partner with countries that don't have vaccine manufacturing capability, to actually give them that capability so they can make their own version of our vaccine, not just centralize its manufacture in one country and then say, sorry, we can't export, so you can't have it.
Yeah, here's my question for you, Nicholas, because I was telling Michael all about this just before you joined. I was intrigued by this notion of a virtual pharma company. In my previous life, I worked in biotech, and I know these are big beasts, your pharma companies. And you pointed out to me the other day, these are run top down by a CEO, zillions of employees, are these giant behemoths, you know, and that's not the way to move quickly. And we were talking about this notion of a virtual pharma company. Tell me how that works with the technology platforms and the partners.
Yeah, so, you know, we've come up with this idea of a virtual pharma company really out of necessity, because we're particularly focused on pandemics and supplying a global market very rapidly when a pandemic occurs, because you don't get really any warning. It's suddenly upon you. How can you do things, you know, incredibly rapidly? And we know that bureaucracies and large companies, you know, just the communication from one level of the company to the other can take weeks or months, if not years, often just to get a basic confidentiality agreement signed with a big company, it might take 6 months, So in that sort of scenario, the idea that they can make a vaccine and get it out in a matter of weeks, just doesn't gel. And
then when the pandemic is over, funding dries up. Nobody's then interested in funding these things anymore.
Exactly. It's really challenging. And we saw that during swine flu. Most vaccine was delivered after the pandemic had passed. And it ended up being destroyed because the big companies delivered it too late to be useful. And so, what we have to have is a system where we can get the vaccine made and out the door, faster than it's ever been done before. And so we came up with this idea that we needed a more distributed system where we actually had a network rather than a hierarchical system. And so really we set about saying, how do we build the essence of a pharma company in a distributed model? So, pharma companies obviously have their scientists, and, they might have 1,000 scientists in a building. Instead of that, we collaborate with, 100 different universities, which, might be 10 scientists in each with whom we're collaborating. So that gives us access to 1,000 scientists, just like a big pharma company, but through a network rather than having everyone hosted in a single building under our employment.
And then you use technology to link everybody?
Of what a pharma company does is you look at what's its functions, and then how do we get access to those functions in a distributed model. And so that's what we've progressively been doing, is just building all of those different layers and structures, but within a distributed global model where we have partners rather than employees. And, we've shown that can be very successful in delivering products very rapidly. And, during 2009, during the swine flu, we had the first vaccine in the world in human trials, and we were competing with some of the world's biggest vaccine and pharma companies. And using our distributed model, we got it there. We had no funds for it. So we did it really for $0, and we still got a vaccine, got it made, and got it into humans and showed it was successful without any of the resources or infrastructure or thousands of people that a pharma company would normally use to achieve the same thing.
Using virtualization technologies in the cloud and...
Exactly, yeah. And, we've always embraced, any cutting edge technology that we think, can make things be done better. I was doing artificial intelligence 25 years ago, during my PhD at a time when people thought we were a little crazy because, we're in a big research institute that was very, cell-based and reductionist. And we came along and said, no, we think we can actually train artificial intelligence to do a lot of the work that we're currently doing. And the looks that you got from these scientists, it's like you've gone to the other side. That's not serious science. That's just make believe.
Yeah, science fiction.
That's right. But I think in terms of how
we built back then, these scientists now use today without knowing it, because they plug into the algorithms that we built and with the machine learning and get answers. And they don't realize that they're actually using tools that we created out of our artificial intelligence, 25 years ago. So now it's just become mainstream.
Sure.
But it's just fascinating. And it's the same people who said we were crazy and this was fanciful are actually using these tools on an everyday basis now. They just don't know that they're actually AI tools.
Right. So in terms of the use of these advanced technologies, whether it's AI or cloud or these various compute resources that are available to us, how much has technology really fast-tracked this vaccine development for COVID-19?
So I think the first thing we have to realize is the technology is not new. Even the cloud is just a new term. I gave a presentation, I think in 1998, talking about grid computing which, if you recall, was the previous version of the cloud, and how that we were going to design, vaccines using grid computing. So even back then, the technology was available, and the idea was there, and so we've been utilizing this. We just watch with fascination how, the names get changed. Certainly, things have got sped up a bit, and the GPUs and CPUs are more powerful. But in reality, the ability to do these things has been around for decades, and it was just that people just don't appreciate the potential of the technology. So I think it's more that the mainstream have caught up to what's possible. It wasn't that the technology hasn't been around for a long time.
But you now have the ability with the supercomputing, the power, the GPUs, all of it, to run a lot more chemicals through every day, every hour than you ever could, say, 3 years ago.
Yeah, no. So for instance, using the Oracle Cloud, like, we're screening millions of compounds to find potential drugs against COVID-19. Now, we're doing those screens in a matter of weeks. I mean, 5 years ago, we could have done the same thing, but we would have been running those algorithms for years.
There's your quantum,
and similarly, the databases have got bigger. So the chemical databases, a few years ago had a few million compounds. Now they have hundreds of millions of compounds. So again, if you want to screen those, we'll need the next generation of cloud and CPU and GPU power, which will come. So it's always advancing, and I think the beauty is that technology never stands still. And so if we're building vaccines in 2 months, today, I would hope in 5 years' time, we'd be building them in 2 weeks. Because that's just the nature of technology. It empowers you, and I guess that's why it's fantastic to work with cutting edge companies, like Oracle, because they understand too that what we're trying to do is push the boundaries, that we're not just trying to do things the same way as we've always done them. And I think they similarly are looking to the future, like, where can we take this technology? How can we use the cloud more efficiently for drug design and for vaccine design? So I guess that's been fantastic to work with a group who similarly embrace this idea that technology isn't just sort of an inanimate object. It's something to be used to better mankind. And in our case, that's finding better drugs and vaccines. So it's great that they share that sort of passion to use it for something meaningful.
Yeah, we will be watching this really closely, Professor Petrovsky. You're morphing into a virtual pharma company, and you deal with Oracle and other tech companies that are really helping further a treatment and a vaccine for COVID-19. Sure can't happen soon enough. Michael, you were going to say something?
I was trying to find out what is the best and happiest ending to this story about vaccine cure, the cure for COVID-19, but also the vaccine itself.
Well, I think the happy ending is a vaccine before the end of the year, or multiple vaccines, and then rolling those out, getting people protected, and actually getting rid of COVID-19, putting it back where it started in bats, but out of humans. And I really believe that's possible in the next, certainly by the end of the year, we'll have evidence that we are going to have successful vaccines. It will take about a year probably to get them out there, sort of, amongst the larger populations. But I think once people can see that we have something, I think people are going to be a lot happier. So I think people understand you can't implement it overnight, but I think the very fact you have something that's going to work, that's what's going to make everyone really happy.
Something to look forward to.
Something to look forward to. Forgot to ask you, Nick, what are you drinking tonight? We have a cranberry juice here in Hong Kong.
I'm drinking water. So
I think Michael too is your water buddy.
I'm drinking water like a responsible person on this Friday.
Yeah, you have to stay hydrated in this job. And but after this, I'll be going off to have a nice South Australian Shiraz red wine. So we're in the heart of wine country here in South Australia. We have
you're in Adelaide.
Best vineyards, like about 20 minutes drive away. So I'll be having some of the local product tonight when I finish work and can relax.
Oh, it'd be wonderful to visit you down there sometime once travel restrictions have been lifted.
All right, that's all the time we have. Thanks so much, Nikolai, for joining us. Please join us for another version of DevOps Drinks. And of course, you can just hit subscribe right there in YouTube, or email us if you've got a comment or a question at devopsdrinks@gmail.com. For DevOps Drinks, I'm Gina Smith.
I'm Michael Araneta.
And we will see you next week.
We'll see you soon.